yes, there is a mistake here, and this is kind of like 14.1, and this is 14.2, and that is just basically a little bit of a formatting error that's removed the number there. So there's two separate questions there. And I've been asked to talk about question 2, the second part of question 14. So it says a supermarket sold 53,000 loaves of white bread, 18,400 loaves of wholemeal bread, 7,200 loaves of rye bread, 12,600 loaves of specialty breads. The relative frequencies of sales in each type of bread, and this is a prior knowledge thing, so we won't be directly assessing this, but it is stuff that you should have seen before. So relative frequencies are for white bread, wholemeal, rye, and specialty. Well, first we have to work out how much bread loaves or how many bread loaves are sold in total. So that's 53 plus 18,400 plus 7,200 plus 12,600, and that's equal to 91,200, I believe. Yes, so 91,200 was sold, and of the white bread, the relative frequency is a probability basically, or a proportion. So it's 53,000 out of 91,200 sold with white bread, and you write this down simplified. And then the next one is 18,400 out of 91,200, and you write that down simplified. Straight away you can take the two zeros off and it will divide by common factors, but you have a calculator for that. The rye bread again is 7,200 over 91,200 equals, and then the specialty bread is 12,600 over 91,200 equals, and write them down simplified. Question B, what is the probability that the next loaf, not oaf, next loaf sold will be wholemeal? And that is basically this answer. So the relative frequency is the probability that the next loaf chosen will be wholemeal. And then this is the expected outcome of the next 200 loaves sold. How many would you expect to be wholemeal? So 200 times by that probability, which is 18,400 over 91,200. Now we'll need to simplify this a little bit now. So let's do some simplification. I get 92 over 456 times 200, and that is equal to 46 over 228. So this is still simplifying, just dividing by 2 at the moment. 23 over 114 times 200, and you'll need to calculate what that is, and that will be your answer to part C. So solve that, and that should be your answer. Round it appropriately, up or down. So there's your answer to question C of part 14, but the second question. Now I just wanted to make a point that I was also asked to do question 28 and question 33, but I forgot to put them on there. So I'll quickly screenshot those now and answer those two questions as well. So question 28, I believe I was asked to do just a particular part of question 28. So here's question 28. Statistics show that more babies are born than more male babies are born than females. Assume the probability of a male child being born is 3/5, so 60%. Consider a family of 6 children. Question A, what is the probability, or are there only 2 outcomes? Yes, there are. Male or female. Question B, are successive burst independent. In this case, we're going to assume yes, although if you speak to somebody within these fields, or perhaps a biology teacher, they may suggest that certain people have traits that give them more likeliness of having successive boys or successive girls, but we'll make the assumption yes. C, can we use a binomial theorem? Why and why not? Yes, we can, because in this case, they're independent and there's only two outcomes. So this is due to A and B, and we know our P and Q. D, calculate the probability of the couple having 3 boys and 3 girls. So the probability of 3 boys, if we call having a boy a success, just for the question, mind you, then we would say that this is, we go to the 6th row of Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 4, 6, 4, 1, 1, 5, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So probably the 3 boys is 6 times 3/5 to the power of 3 times 2/5 to the power of 3, and this is equal to 6 times 27 times 8 over 5 to the power of 6, and we can obviously calculate this as need be, so I'll just quickly do it. That's 162 times 8, which is 1296 over 5 to the power of 6, which is something large, and we'll be able to calculate that probability from there. So that's D part 1. D part 2 is the probability of 4 boys. So in this case we go along to, my apologies, that part 1 is not 6 at all. It is 20. So that's 20, which means instead of 1296, we cancel out one of the 5's, making this 5 to the power of 5. We've just got 4 on the top, which is now 108 times 8, which is 864 over 5 to the power of 5. My apologies there. Probably of 4 boys is now 15 times by p to the power of 4, which is 3/5 to the power of 4 times 2/5 squared, and obviously we'll end up with 5 to the power of 5 on the bottom again, because 1 5 will cancel out with the 15, leaving us 3 times 3 to the power of 4 times 2 squared, and I might just leave that as 3 to the power of 5, 2 squared over 5 to the power of 5, and again you could evaluate that in your calculator. And then part 3 is the probability of at least 1 boy, and the probability of at least, so that's 1, 2, 3, 4, 5, 6, boy is equal to 1 minus the probability of 0 boys, which in this case is 1 minus 1 times q, which is 2/5 to the power of 6, that's all girls, 1 minus 2 to the power of 6 over 5 to the power of 6, and again you can evaluate that as appropriate. And there's your answers to question 28, and then of course I've just promised to do question 33, which I've got, if I've got it right, should be a simultaneous equations question. So in fact I might just do one part of 33. So I'll do question C. So question C here, and those people who have asked me about this one can come and ask me separately if they need any more help. Equals 11, and y equals 2x minus 1. So we're given 1 and 2. I'm going to use number 2, y equals 2x minus 1, and I'm going to sub that into number 1 to give me 2x minus 3 bracket equals 11, and inside of that is going to be my 2x minus 1, because that was a y, but y is equal to 2x minus 1, so therefore it's become a 2x minus 1. Swapping y out for what it's equal to. And now I just need to simplify this. 2x minus 6x plus 3 is equal to 11, which means that negative 4x plus 3 is equal to 11, which means that negative 4x is equal to 8. Subtract 3 from both sides, which means that x is equal to 8 over negative 4, which is equal to negative 2. And if x is equal to negative 2, then y is equal to 2 times negative 2 minus 1, which equals negative 4 minus 1, which equals negative 5. And obviously I use equation 2 there, so I verify in number 1. My verification equation number 1 is 2 times x, which is negative 2, minus 3 times y, which is negative 5, and that gives me negative 4 plus 15, which gives me 11, which is what I required. So there's my answer to question 33, and I believe I've answered all your questions.